good day to all. My name is Rohit Balachandran and I am doing Master of Mechanical Engineering in University of Gurgaon. Today my topic for the presentation is testing of a new lubricant in metal forming. So first of all I'd like to give you a general introduction regarding what is actually metal forming. Metal forming is a general term for a large number of manufacturing processes. In the process of metal forming, the metal is plastically deformed into a shape that the user desires. Metal forming is generally used, this process is generally used in a large, wide range of industries like automobile, aerospace, and even every single items that we use like nuts, bolts are made using the metal forming process. There are a wide variety of metal forming processes. Some of the major processes are rolling, forging, extrusion, shearing, bending, and drawing. One of the major problems that we face during the metal forming is the friction that occurs between the tool and the workpiece, and which result in adhesion and wear occurring in the piece. So in order to avoid this, we use lubricants. The lubricants are added to the tool and the work interface in all metal forming, which in turn reduces the wear rate and the adhesion that occurs between the surfaces. The major advantages that the lubricants provide us are it reduces the sticking, that is the sticking that occurs between the tool and the workpiece. Then it reduces the power required will be very less. That is, if lubricants are used, the amount of power that we have to provide to push the metal piece is less. The tool wear is reduced. If there is if the tool wear is high, we have to change the tool piece after each cycle. The heat during the next is that the heat during the machining process is reduced. If the heat increases, this in turn the shape of the metal in turn changes, and which does not give us the required shape. A wide range of lubricants are used during metal forming. Some of the major lubricants are metallic solids, oil type fluids, that is for example chlorinated paraffin oil, aqueous dispersion solids, and solid lubricants. The lubricants used right now have many disadvantages. The lubricants used right now are not environmentally friendly. Many chemicals like chlorine, sulfur, phosphorus, etc. are used in this process. So this is not eco-friendly. Although lubricants are used, the efficiency that we get from this process is very low. The wear rate from the commercial lubricants that are being used right now is very high, and there's need for a replenishment. That is, after every cycle, the lubricants have to be replenished. It does not stay. So this led me into thinking and brought me an idea that is, why can't we use a lubricant that is eco-friendly and can be used in a repeated number of cycles. And I came to the conclusion, why can't we use coconut oil as a lubricant with some additives added to it. So now I'll give you a general idea about coconut oil. Coconut oil is basically a type of vegetable oil. It's available in large quantities in the southern states of India. Basically, coconut oil is 51% of lauric acid, and this is although it's an acid, it's totally environmentally friendly. The structure of the coconut oil has a triacyl glycerol structure. It consists of 94% of saturated fatty acids. So this is a major advantage, and this enhances the lubrication properties of coconut oil. The major properties of coconut oil are, first one, its viscosity index. The viscosity index of coconut oil is high. That is, at high temperatures, the viscosity of coconut oil does not decrease. So this in turn, it remains thick even during the forming process. The next is the flash point. Flash point is, in general, is the temperature at which the oil might vaporize. So for coconut oil, it's high. So in general, the flash point is high. The oxidation stability. Coconut oil has a low oxidation stability, so if oxidative inhibitors are added to it, its stability can be increased. Pour point. Pour point is the lowest temperature at which a liquid can flow, and for coconut oil, it's very low. So this is an added advantage for coconut oil. The anti-wear properties of coconut oil is also very high. So all these properties are advantages for coconut oil being used as a lubricant. In the previous studies conducted, it was found that this oil is used in a large number of two-stroke engines in different states of India. So Mr. Jayadas, he conducted a test on a 4-ball tester using the additive zinc dialkyl dithiophosphate. The major variants that were tested were the coefficient of friction and the wear that occurs to the tool piece. So the advantages that they found is that the coefficient of friction improved a great deal. The wear scar diameter was reduced when the additive was added, but it had a major disadvantage. That is, the wear scar diameter reduces only when the additive is added to it. So I came up with a research design in which we add a particular additive that can make coconut oil the best lubricant. So the chemical composition of coconut oil was first studied, and its different components were analyzed. Then the different additives were analyzed in such a way that it can be mixed easily with the oil. The experiment that we used was the pin on disc experiment, which you can see in the figure given. So after the analysis, it was decided that we use molybdenum sulfide as the additive. So molybdenum sulfide was added in different quantities, that is 1, 0.75, 0.5 and 0.25. Then these quantities were mixed in different proportions using an ultrasonic shaker. The lubricant was added dropwise between the pin and the disc. The pin had a heating coil which would measure the temperature. The roughness value of the pin and the disc were noted. The parts were measured. The weight of the parts were measured so that we can know the wear, and so in turn we can calculate the friction that occurs. From the results obtained, we found that the roughness value of the pin varied from 0.27 to 0.32 micrometer, and the disc varied from 0.15 to 0.16 micrometer. The coefficient of friction was reduced a great deal when the temperature was 75 degrees Celsius. And from the results, we found that the optimum composition of molybdenum sulfide was 0.53. The wear rate reached an acceptable value of 0.883. And hence we can conclude that molybdenum sulfide is at an ideal concentration of 0.53 is an ideal lubricant that can be used along with coconut oil. And this in turn proves that coconut oil is one of the best lubricants that is eco-friendly and environmentally friendly. But even though we concluded that there were some limitations, that is, even though this molybdenum sulfide added, it reduced the friction and the wear. If the concentration of molybdenum sulfide varied plus or minus, then the wear rate and the friction completely damages the workpiece. When it is kept stationary for some time, the coconut oil has a tendency to settle down, and so this makes it unsuitable for certain applications. And finally, the experiment proved to be a little costly, so new researches have to be conducted which can help in reducing the cost. Thank you.